Back in my vector tutorial. In this stage I'm trying to show you questions from exercise 13.4 and is the last exercise of vector chapter. Here I'm trying to show you some of the question from here. The question first one is written here: displacement and time taken 6 seconds, find the velocity vector. So velocity vector, we know velocity we can write here. You may see the example of this book example. There are a lot of good examples are there to actually make you understand this one. Displacement, we can write displacement divided by time to get the velocity vector. So here the displacement is given 21I plus 54J, then the time is given 6 seconds and it's in meter and another one is second. So just cut out from there 21, we can write it 21 by 6I, then another one 54 by 6J. So we would get, so cut out with the 3 is 7, 3 to the 2, so which is 7I by 2. Our vector is 9J. Here the vector comes out in terms of I and J. Actually we know that I is the unit vector in the x-axis and J is the unit vector on the positive y-axis. That's the total information, and its unit is definitely meter per second because information displacement provided with the meter and time is second written there. Hope guys you understood the way we did the question. The second question is velocity given and time given, they're asking to find displacement, so it's easy as well. So displacement you can find out, displacement we can find out velocity by doing the velocity into time. Its velocity is given, let you write 5I minus 6J, and its time is given 6 seconds. So just multiply and actually remove the bracket from there. 5 6 the 30I minus 6 6 the 36J. So this is our displacement vector, and definitely its unit we need to write in meter because displacement there is no time, that's why we need to write like this. Hope the way we did the question you understood. And the last question from here, which is C, velocity given, they're asking displacement given, they're asking to find out the time. So we know displacement we can write directly the velocity vector into time. So if we make time as a subject, we needed to write d by v. So displacement vector, let you write the displacement vector, which is minus 50I and plus 50J, and the time is given minus 4I plus 4J. From on the top part, if we take 50 common, then inside it is minus I plus J, and the bottom part it would be, if I take 4 common, minus I plus J. So we can cut out these two, and the time gives us 50 by 4, and its unit is, we can write in hour because it is written kilometer per hour, so it's come the hour. So just we needed to write in a mixed fraction, or we can write also in the hour and minute. I think you know how to write that, so I am keeping my answer like this, 50 by 4 hour. So this is the total working from the question number 1. In this stage I am going to move to the next question, question number 2. Stay tuned in my tutorial. Provided a car travels from a point A with position vector this and to a point B with a position vector that, the car travels with constant velocity and time and takes 5 hours to complete the journey, find the velocity vector. It is very easy. So we can write velocity vector as a final position vector, we can say SF, and its initial position vector, which you can say S initial, and if we divide with the time, then we can find out the velocity vector from here. So from A it moves to the position vector B, so the final vector we have to write this one, minus 50I plus 18J, which is the final position, minus its initial position, which is written 60I minus 40J. We're going to subtract this one, so 60 minus 60I plus 40J, because there is a minus sign in front of it. If we put a minus sign, then minus 60 minus plus 40J we have to write. and time taken in this journey 5 hours is given. Let you divide with the 5. Now add the I part, minus 50 minus 60, which is minus 110i. Then another part is 40 plus 18, which is 58z, and we're going to divide with the 5. We can do that by using a calculator. Let's see our calculator working. If we divide 110 by 5, 110 divided by 5, we got from there 22. So let you write minus 22i, then next one plus 58 by 2. What is that? Plus 58. Let you divide 58 divided by 5. So what the value coming out from here? It is 11.6. So we can write 11.6z, and j is a unit vector, I is a unit vector. This is the answer of this question, velocity vector. So similar type questions are in question number 3. Let we move to the question number 3 now. Written in helicopter flies from a point P position vector given to a position vector Q, and the helicopter flies with constant velocities given there, and it takes 2.5 hours to complete the journey. Find the position vector of the point Q. So how to do that? Actually, it have to do like this way. Velocity vector, you can write final position, which is OQ given, and initial position, which is OP. If we divide with the time, then we would get the velocity vector. So we can write OQ directly, say OQ. If we make OQ as a subject, then we can write the velocity vector into time plus OP. So this is our equation. Let me put our value. OP is position vector. This is the OP vector. So let's write 50i plus 100z is OP vector, then plus velocity vector into time. So our velocity vector is given here, constant velocity, which is 30i minus 40z into its time is given here 2.5 hour. So 2.5 hour. So break down this one. 50i plus, if I multiply 30 with 2.5, which gives us 60 plus 15, 75i. Yeah, let you write 75i. And another part of the z coefficient 100z, and minus 40 into 2.5, which gives us 80, and I think plus 20, 100. So minus 100 z we can write from here. So finally we would get 100 you can cut out. 50 plus 75, which is 125i, is our velocity vector in that direction. Position vector of find the position vector of Q. This is the answer of the position vector of Q. So hope guys the way I did the question you understood. And from question number 4, it's a type different, 4, 5 especially. I'm going to show the next tutorial. I hope you enjoyed the way we did the question, and you stay tuned to see my next tutorial as well. Thanks for watching with patience.